As I have already explained throughput in my last video, once again we will understand throughput in computer networks through these examples. So here in this example, throughput, once again, who has still some confusion in throughput. Throughput is on an average, uh, receiver is receiving how many bits per second. So what is the rate at which receiver is receiving on an average number of bits? It is also will calculate in terms of bits per second. And there are two types of throughputs for differentiation purpose. So at a time in a network, so suppose at a time t, what is the throughput? So if you will calculate the throughput at a particular time, that is called instantaneous throughput at a time t. Whereas the another one, which is broadly being used as a performance parameter, that is called average throughput. So on an average, within stipulated time frame in time period, how many bits have been received properly at the client side or at the receiving side. So that is called the average throughput. So here there's a client and there's a server, and it is connected through an intermediate router. This link capacity is RC, which is connected to client, and the link capacity with server is RS. The link capacity, once again, for your reference, the link capacity is equivalent to the transmission speed, the transmission rate. By what rate can you push uh, your bits over a wire? So server can push in 1 second RS number of bits, client can push RC number of bits, and this intermediate router, depending on the interface uh, on which the link is connected, either can transmit it with a speed of RS bits per second or RC bits per second. So here, if we have to calculate a throughput, one more uh, thing which you have to remember here, throughput can go maximum up to the link speed, the link transmission speed. So here we will calculate the average throughput. So what will be the average throughput in between server and client where two links are there? When there was only one link, so if we have to calculate the average throughput in between this router and this link, the maximum throughput can go up till RC, because this is the number of bits which you can push over the wire at a time. In 1 second, RC number of bits can be pushed over a wire. So that is the maximum throughput which you can send from here to here in 1 second. That is if there is only one link in between these two. But here in between server and client, there are two links. So obviously here the average throughput will go, and the maximum of that average throughput will hit the ceiling, where the ceiling would be defined by the equation, and the equation is minimum of RS and RC, whatever be the minimum of RS and RC. So that bottleneck that bottleneck link will define the average throughput, because suppose if RS is this RS value is 5 bits, 5 Mbps, and RC is 1 Mbps. So client can push and client can receive at the transmission speed of 1 Mbps, whereas server can receive and send both at the speed of 5 Mbps. So the bottleneck link here is 1 Mbps. So obviously, in order not to accumulate so many packets inside the buffer at intermediate nodes, because then the packet loss will be the serious concern. So to avoid packet losses, the bottleneck throughput will be, so the server and client will adjust the flow. So RS though is 5 Mbps, but server will push the bits over wire at the speed of 1 Mbps, so that there will be a match with RC. Same way here also R1, R2 until Rn. So here also if there is any weak link, so that bottleneck link will define the average throughput. So whatever be the minimum of R1, R2 till Rn, so that define the maximum average throughput. So here if it is 10, 8, 7, 6, there are different range of Mbps values, transmission speed. So if there is any link with the smallest value is 2 Mbps. So in between server and client, the average throughput which can go, which can reach, which can hit the ceiling is 2 Mbps. That is one clarification regarding throughput. So here Uh, it is a network core. Here the server and client. Client is connected through network core and intermediate. There are inside this core there are several intermediate routers as well. But generally, we consider because these big organizations maintain the network core and they always invest in future. They always provide good infrastructure, so the bandwidth is not an issue here, so there is no bottleneck here. And generally servers are also maintained by big organizations, so when they uh, serve their client through network core, and when they access the network core through this access network, so obviously they subscribe to with highest bandwidth because they have to serve several clients across the world. So there also RS is not sort of a bottleneck here. But as a client, because we are poor people and we can't afford the high bandwidth, so we generally access the network with the least bandwidth possible. So this RC is the bottleneck. So that's why when as a client you access any server and you are facing any serious bottleneck issue, so it is probably more on your side rather than believing that it is on the server side or the network core side. But sometimes even it may possible that in the network core, because it is highly dynamic, so these are 10 clients which are connected to 10 server and there is one link somewhere. It may be it because it is based on probability that because the packet switching network is not static, it is highly dynamic. Even one packet where it will go, you never know. So here if these 10 clients are connected to 10 server and at a particular time by any chance they all are starting using any one link here, though that link capacity may be high, but it may be possible that these all 10 will start using that link having any capacity, the highest capacity. But once all these 10 devices, servers and client will start using a single link, that will act as a bottleneck because then that link has to be shared in terms of different channel across different client server interactions. So that will become a bottleneck. So sometime, but the chances are rare, the chances are less that any link, because nowadays the routers, the infrastructure is smart. They recognize these type of bottleneck situations quickly, and then they do the load sharing thing. So that's why the routing there is dynamic. So that's the extra thing about the throughput. In the next part, we will understand the layering architecture, which ensures the modularity in the design framework of all the protocols, design framework of the network.